Assalamualaikum and hello guys. We continue with our 1.5 about isomer. Okay, what is isomer? Isomer is the existence of different compound with the same molecular formula but different structure formula. It will be called as isomer. Example here, C4H10 here, what we call is as same molecular formula. This is molecular formula, but different structure formula. This is the different structure formula. This is linear. This is the structure that have a branch. Constitutional structure isomer are isomer with the same molecular formula but different structure formula due to the difference in the order of attachment of atom. This is example. Constitutional isomer can be classified into three: chain isomer, position isomer, and functional group isomer. For the first one, chain isomer, the isomer differ in the structure of the carbon chain or differ in the length of straight chain or branch. Example here, C4H10. The first structure have 4 carbon, the second structure also have 4 carbon. What is different? The straight chain here consists of 4 carbon, but here the straight chain consists of 3 carbon, then it have a branch. Here we call it as chain isomer when we compare structure 1 and structure 2. For the second one is position isomer. It refers to isomer have a functional group or substituent group in different position. Okay, functional group. Make sure you still remember about functional group. This is the molecular formula C3H7Cl. We look at the functional group or substituent group. Example here is functional group. Cl is functional group. It located at carbon 1. The second one, the second compound here, Cl, the functional group located at carbon 2. Thereby, when we compare structure 1 and structure 2, it is position isomer, the different position of the functional group. The third one, we call it as functional group isomer. Okay, what is functional group isomer? This isomer have different functional group and belong to different homoloxy with the same general formula. It will have the same general formula, but it will have different homoloxy. Alcohol and ether will have the same general formula but different homoloxy. Carboxyl acid and ester, alkene and cycloalkane, aldehyde and ketone. Okay, example here, alcohol and ether will have the same general formula, but alcohol, this is the structure of alcohol and this is the structure of ether. A different functional group. This is OH, this is O, R and R. And carboxyl acid and ester will have the same general formula, but this is the carboxyl acid, the functional group is C double bond O OH. For ester, the functional group will be C double bond O O R. And for alkene and cycloalkane, the general formula will be same, but the different, if you look here, this is alkene, and this is cycloalkane. This is saturated, this is unsaturated. And for C5H10, the same general formula is the aldehyde and ketone. This is aldehyde, C double bond OH, and this is ketone, C double bond O, R and R. That is the functional group isomer for the constitutional. Okay, and then 1.6 is about the basic reaction in organic compound. The first one, all chemical reaction involve breaking and formation of bond. There are two types of bond cleavage. The first one is homolytic cleavage. The second one is heterolytic cleavage. What is different between homo and hetero? The first one, homo cleavage mean a bond fission. Bond fission is break the bond, in which the two share electron of the covalent bond are split equally between two bonding atoms. Example here, Cl and Cl. Okay, when we have UV, the UV will be used, the energy here will be used to break the bond. Okay, and then what happened? Each of the Cl will get same amount of electron. Split equally between two bonding atoms. Homolytic cleavage occur in a non-polar bond involving two atoms of similar electronegativity. This is the same atom that have the similar electronegativity. A single bond will be break symmetrically and each bonding atom will receive a single electron. Thereby, after the reaction occur, it will produce free radicals. This is the free radicals. This we call it as homolytic cleavage. The arrow, make sure half-headed arrow is used because only one electron is transferred for each of the atom. And heterolytic cleavage is a bond breaking in which both bonding electrons are transferred to be more electronegative bonding atom. Example, we can look here at this example. C and Cl will have different electronegativity because this is difference element. Cl is more electronegative, the electron will be pulled to Cl. What happened? The bond between C and Cl will be break non-symmetrically because Cl is more electronegative. And then what happened? Transferred to the more electronegative bonding atom. The electron here from C will be transferred to Cl. Thereby, Cl will be rich with electron. You will get Cl minus, and C will have less of electron. It will be carbocation. From the heterolytic cleavage, it will produce the cation and anion. And we will use full-headed arrow here because two electrons are transferred. Okay, that is about the homolytic and heterolytic cleavage. And then we have types of intermediate. We have three types of intermediate: free radical, carbocation. What is mean by carbocation? Carbon, it will have the positive charge. Carbanion, the carbon that will have negative charge. Free radical is an uncharged atom, it will not have charge. Molecule with an unpaired electron, it only have unpaired electron. Example for your free radical. Okay, free radicals such as C dot here mean this is unpaired electron, this is free radical. And C plus mean this is carbocation. This is carbocation. Carbo is carbon, this is carbon. Cation is positive charge, this is positive charge. And then carbanion. Carbanion is refer to the carbon, but anion mean negative charge. Okay, and then we look at the stability of free radicals and carbocation. Okay, if you look here, for the carbocation and free radical, it will have the same stability. CH3 plus R CH2 plus. Okay, here is methyl. Here is primary carbon. Why primary carbon? Because C here, carbocation here is bonded to only one carbon. R here is referred to alkyl group. And the third here, carbocation here is bonded to two other alkyl group. This is the secondary carbocation, and here will be tertiary carbocation. Okay, alkyl group are electron donating group. Alkyl group are here, alkyl group. Thereby, it will help to disperse the positive charge on the carbocation or free radical. What we understand that C plus mean it has less of electron. When you have R, the alkyl group is electron donating group. It will donate the electron here. When you have many alkyl group that will donate the electron to the carbocation, it will make the carbocation will be more stable. Thereby, the tertiary carbocation will be more stable compared to secondary, compared to primary and methyl. It will be same for the free radicals. And after that, we look at the type of reagent. Reagent for organic reaction can be classified into two types. The first one is electrophile, the second one is nucleophile. Very important to understand what is electrophile and what is nucleophile. Electrophile is an electron deficit species and electron pair acceptor. Electrophile means it has less of electron, such as C plus. Electrophile, okay, such as any of the element that have positive charge. Electrophile will attack a site with high electron density. Electrophile species can be neutral or positively charged. Example of our electrophile, cation, positive charge. Positive charge, it show the positive charge. Or we can look at the Lewis acid. It will have no lone pair at the center of the atom. Example, okay, we have AlCl3, when we draw the Lewis structure, it will be like this. Okay, no lone pair at the center of the atom. This is the center atom. No lone pair. No lone pair. Thereby, it cannot donate the electron. Same as for BF3. BF3, when we draw the Lewis structure, we'll get B, F, F. No lone pair will be at the center of the atom. Thereby, it will be Lewis acid. And then, the third example is carbocation and oxidizing agents such as Br2, Cl2, and any of the electrophilic side. C double bond O, this is less of electron. Why? Because O is more electronegative. O will pull all the electron from C. Thereby, C will have less electron. This is electrophilic side. CX, X is your halogen. Halogen is more electronegative than C. Halogen also will pull all the electron from C to itself. And the third example is COH. This is the electrophilic side. And the nucleophilic side. Nucleophile is an electron. It will be rich species. An electron pair donor. Nucleophile means it will rich with electron. Nucleophile will attack a site with low electron density. Example here, this is your nucleophile, my dear. Your nucleophile, it will attack the place that will have the less electron density, such as C double bond O. The nucleophile will attack the site here. Nucleophile can be either neutral or negative charge. This is example of our nucleophile. The anion, easy to find it because it consists of negative charge. Lewis base. Lewis base means at the center of the atom, it will have lone pair, rich of electron. Example here, your NH3, my dear. NH3, when we draw our Lewis structure, N, H, 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 we have one lone pair here. Mean this is nucleophile. It has a lot of electron and it can donate the electron. And then carbanion, nucleophile side lah. Okay, here C double bond C and C triple bond C, it show you the rich of electron at this side. And also benzene. Okay, and then the last one is about the type of organic reaction. There will be three types of organic reaction. That is substitution reaction. You know what is mean by substitution? Substitution mean tukar ganti. Substitute. And then additional reaction, tindak balas penambahan. Elimination reaction, eliminate, singkirkan reaction. Substitution reaction is a reaction in which an atom or group in a molecule is replaced by another atom or group. Substitution means substitute lah, tukar ganti. Bukan buang ya, tukar ganti. There are three types of substitution reaction. It will be free radical substitution, electrophile aromatic substitution, and nucleophile substitution. Okay, what exactly is free radical substitution? Free radical substitution exactly substitute which involve free radical as intermediate species. You will get the free radical as your intermediate species. Okay, and homolytic cleavage because bonding atom have similar electronegativity. Yeah, you will have same bonding atom. Okay, homolytic cleavage using UV, then it will produce free radical substitution. Okay, and then the second one is electrophilic aromatic substitution. The type of reaction it will be occur to your aromatic compound. The aromatic nucleus has high electron density, thus it is nucleophile. This will be your nucleophile, my dear, richly electron, double bond, double bond, double bond, okay, and is prone to electrophilic attack. Thereby, when we use Br2Fe with the catalyze, you will get the substitution. Hydrogen will be replaced by Br. Okay, this we call it as electrophilic aromatic substitution. And then nucleophilic substitution. Okay, example here, typical reaction of saturated organic compound bearing polar bond as functional group. This is example. This is your haloalkane. Nucleophilic substitution. Why substitution mean tukar ganti? This is nucleophile. You replace your Br with OH minus. How you know replace? You look at the product. Br will be replaced with OH. Thereby from haloalkane you will get alcohol. This we call it as nucleophilic substitution. And addition reaction in which atom or group add to adjacent atom of a multiple bond. Two type of addition reaction. There will be electrophilic addition and nucleophilic addition. That is example. Electrophilic addition. Electrophilic addition. Why? Because this is rich with electron, initiated by an electrophile which attack a nucleophile site of a molecule. Thereby, if you look, the bond will be break here. Addition means add. You add the electrophile. When you break the bond, double bond, it will be single bond, and then you add the electrophile, Br and Br. Okay, and then the last one is about the nucleophilic addition. Nucleophile addition, how initiated by a nucleophile which attack an electrophilic site of a molecule. This is your nucleophile. Okay, it will attack your C double bond O because this is the less density of electron. Yang ini kaya dengan elektron, jadi dia akan serang bahagian ini. Attack C double bond O. What happen when attack here? The double bond here will be break, and Cn will be added to carbon here. You get Cn, and O here will be added H. From here you get OH. This is nucleophilic addition. And for the last one is about the elimination reaction. Elimination reaction, from single bond you will get double bond, or from double bond you will get triple bond. This is OH. You eliminate OH. You eliminate one hydrogen here. Thereby, it will produce double bond. This is example of elimination reaction. Exactly, to know the type of reaction, you have to look at the reactant and you have to look at the product. It will help you to know which will be the types of the reactions. Okay, that's all for today, my dear. Hoping it will help you to understand this topic. Any problems? You can ask me using the WhatsApp. Okay, Assalamualaikum and thank you.